Good evening. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. My name is Leon Jones, and this evening I'm going to get into another math topic. And the topic today, or this evening, is calculus. So the title of this video is What is calculus and how is it used? What is calculus and how is it used? Now, one thing you need to understand about calculus is a branch of mathematics that involves the study of rates of change. Before calculus was invented, mathematics was static. And when something is static, that means it's not moving. Now, when it came to math in the past, it could only help calculate objects that were perfectly still. But one thing you need to know about matter in general, along with the universe, is it's constantly moving. So when it comes to objects from the stars to subatomic particles or even cells in a body, they're always at rest. However, when it comes to matters of the universe again, everything is constantly moving. So, when it came to mathematics, something had to be done to calculate the movement of objects. And that's where calculus came into play, because calculus helped to determine how particles, stars, and matter actually moved and changed in real time. Now, one thing you need to know about calculus, it's used in a multitude of fields that you wouldn't ordinarily think make use of its concepts. One I can tell you is engineering. Two is economics. Then you have statistics, physics, and medicine. Calculus is also used in such disparate areas as space travel, as well as determining how medications interact with the body and even how to build safer structures. You'll understand why calculus is so useful in many areas if you know a bit about its history as well as what it's designed to do and measure. Now, here are the key takeaways from the theorem of calculus. Calculus is the study of rates of change. Now, you had two mathematicians, one Gottfried Leibniz and of course Sir Isaac Newton. They were 17th century mathematicians. They both created calculus independently. Now, Newton invented it first, but Leibniz created the notions that mathematicians use today. Number three, when it comes to calculus, there are two types of calculus. There's differential calculus, and that determines the rate of change in a quantity, while there's integral calculus, and it finds the quantity where the rate of change is known. Now, when it comes to calculus, one must understand that there are practical applications. Many of us look at the theory behind calculus, but calculus has many practical applications in real life. Some of the concepts that use calculus include motion, electricity, heat, light, harmonics, acoustics, and astronomy. Calculus is also used in geography, computer vision, such as for autonomous driving of cars, photography, AI, which is artificial intelligence, robotics, video games, and even movies. Calculus is also used to calculate the rates of radioactive decay in chemistry and even utilized to predict birth and death rates, as well as the study of gravity and planetary motion fluid flow, ship design, geometric curves, and bridge engineering. Now, in physics, for example, calculus is used to define, explain, and calculate motion, electricity, heat, light, acoustics, astronomy, and dynamics. Now, Einstein's theory of relativity relies on calculus, which is a field of mathematicians that also helps economists predict how much profit a company or industry can make. And in shipbuilding, calculus has been used for many years to determine both the curve of the hull of the ship using differential calculus, as well as the area under the hull using integral calculus, and even in the general design of ships. Now, in addition, calculus is used to check answers for different mathematical disciplines such as statistics, analytical geometry, and algebra. Now, economists use calculus to predict supply, demand, and maximum potential profits. Now, supply and demand are, after all, essentially charted on a curve, and an ever-changing curve at that. Now, economists use calculus to determine the price elasticity of demand. They refer to the ever-changing supply and demand curve as elastic, and the actions of the curve as elasticity. Now, to calculate an exact measure of elasticity at a particular point on a supply or demand curve, you need to think about infinitesimally small changes. I'm going to say really small changes, exponential small changes. And that's basically in price. And as a result, you have to incorporate mathematical derivatives into your elasticity formulas. So calculus basically allows you to determine specific points on the ever-changing supply and demand curve. Now, one is going to ask, when we talk about the different branches of calculus, okay, there are two branches, like I said earlier in this video: differential and integral. Again, differential calculus studies the derivative, and integral calculus studies the integral. But there is more to it than that. Differential calculus determines the rate of change of a quantity. It also examines the rates of change of slopes and curves. Now, this branch is concerned with the study of the rate of change of functions with respect to their variables, especially through the use of derivatives and differentials. The derivative is the slope of a line on a graph, and in order to calculate a slope in algebra, we use the rise over a run. Now, when you find a slope in calculus, you use the same formula, the rise over the run. Now, when we get into integral calculus, by contrast, it seeks to find the quantity where the rate of change is known. See, this branch focuses on the concepts as slopes of tangent lines and velocities, while differential calculus focuses on the curve itself. Integral calculus concerns itself with the space or area under the curve. Now, integral calculus is used to figure the total size or value, such as lengths, areas, and volumes. Now, here's where calculus played an integral role. And I'm going to give you an example right now. See, in the early 17th and 18th centuries, calculus was used in a role when it came to the development of navigation. Why? Because it allows sailors to use the position of the moon to accurately determine the local time. So to chart their position at sea, navigators needed to be able to measure both time and angles with accuracy. So before the development of calculus, ship navigators and captains couldn't do either. Now, when it comes to calculus, both derivative and integral, what it has done is basically help to improve the understanding of this important concepts in the terms of the curve of the Earth, the distance ships had to travel around the curve to get to a specific location, and even the alignment of the Earth, seas, and ships in relation to the stars. Now, I will tell you this. Before you get to calculus, you have to understand algebra and trigonometry. Because when we deal with mathematics, each course builds upon one another. And when you get into physics, there's calculus-based physics, calculus-based statistics, calculus-based statics, dynamics, and mechanics of materials. Algebra and trigonometry are the basis, because algebra and trigonometry help you understand analytic geometry, vectors, and there is a subject called pre-calculus, where you deal with a lot of functions. Now, if you saw my other two videos, I talked about algebra and trigonometry. Because if you don't understand those topics, you will never be able to do calculus. Because when we talk about calculus, we're talking about a branch of mathematics that involves the study of rates of change. And that concludes this topic on calculus. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some controversial topics, check out the 411 Talk Zone radio show, also on YouTube. And if you want to get more in depth with STEM and controversial topics, check out the 401 Talk Zone radio show on Blog Talk Radio. 215-383-5785 is the number. Now, if you cannot find me on YouTube or Blog Talk Radio, simply check me out on Twitter, MeWe, and of course, Parler. But again, I thank you for viewing and listening to this topic of calculus right here on the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. Please have a wonderful and gracious evening.